Okay, it's good. We can continue if you want. We are very happy to welcome Neil TREVETT from the Khronos Group to the next keynote. Sorry, Neil, you can take the stage.
Yep. Hey everyone. Happy to be here. I'm actually physically in California, so it's 4 a.m. in the morning here, so I'm getting jet lag even though it's a virtual conference. But I'm very happy to be here. It's a very interesting experience. So I'm going to speak for a few minutes on what the Khronos Group is doing with regards to augmented reality and virtual reality. As Gregory said, my name is Neil TREVETT. I work on developer ecosystems at NVIDIA, and I'm a president of the Khronos Group. So I'm going to talk about open standards for XR, as we call it, and how they work together, not just Khronos standards themselves, but how they work together with the larger constellation of standards that are in the industry that is going to enable us to build the dream of the metaverse. So let me get going here. Yes, the button's working good. So let me start by introducing Khronos. If you haven't come across us before, we're an open standards organization. We are focused on creating interoperability standards to enable applications to access the power of silicon acceleration for things that need acceleration, for things like 3D graphics, obviously virtual and augmented reality, parallel computation, and increasingly vision and inferencing acceleration for machine learning. We are a non-profit, and all of the standards that we create are open and royalty-free to the industry to use. We have almost 160 members now. Everyone from NVIDIA and Valve and Google, all the way down to small single-person startup companies spread out across the world. And we're open to any company that wants to join and have a voice and a vote in how all of these standards I'm about to talk about evolve. So if any of this is interesting to you, consider whether you'd like to join in and help us build out this ecosystem. So here's a picture of the most active standards that are currently being developed by the Khronos Group. We put them into 4 main groups. There's the 3D acceleration APIs. There's new generation Vulkan, OpenGL, and WebGL for your browser. There are 3D asset formats, including gltf. There's the Open XR API for portable, augmented, and virtual reality. And on the right-hand side there's languages and APIs for parallel computation. Today, I'm going to focus on the highlighted standards that are most relevant to this AR and VR audience. And I'm going to start with Vulkan. So Vulkan is a new generation 3D API. It replaces the older generation OpenGL. The difference with Vulkan, it gives you much more low-level explicit control over your GPU hardware. So it's a way that developers can get the highest performance and the lowest latency, which is important for VR and AR. Vulkan is unique. It's the only new generation GPU API that is an open standard. The others are from platform vendors like Microsoft and Apple, so they run only on that vendor's platforms. But Vulkan is now being shipped by every GPU vendor. It's being adopted by all of the leading games and applications engines. It's available on almost every platform, desktops, mobile, consoles, embedded systems, as well as the cloud. We're not allowed to ship Vulkan drivers on macOS and iOS, but there are layering solutions, so you can run your Vulkan applications even on Apple platforms. So for developers that are interested in the highest performance, lowest latency XR experiences, and for developers that want to develop once and deploy their applications almost anywhere, then Vulkan, I think, is a very interesting choice for an API to develop your 3D applications in. To give a update on the roadmap, we've just shipped Vulkan version 1.2. It shipped in January this year, and that integrated a number of proven extensions, including timeline semaphores, so people can do multi-threading much more easily. The new functionality now we're discussing the working group are on the right-hand side, and they include things like ray tracing for increased visual reality, variable rate shading, hardware-accelerated video encode decode. For the XR community, variable rate shading, which is where you can focus the power of the GPU on a particular area, is really interesting for eye-tracked systems. You can focus the power of the GPU where the end user is looking in the scene at this point. So that can give you significantly increased performance or reduced power consumption if you're on a battery-powered device. All this new functionality is going to ship first as extensions, and those that get a thumbs up from the developer community are strong candidates for us to put into the next core specification, which happens about every 18 months or so. So in fact, the first item on that roadmap, ray tracing, has already just shipped in March as a set of extensions that seamlessly integrate this new technology into the existing Vulkan framework. This is a significant milestone as it's the industry's first cross-vendor, cross-platform standard for ray tracing acceleration, and it can be widely deployed whether or not your GPU has the new generation of dedicated ray tracing acceleration. Many developers, I find, when I talk to them and when they first encounter ray tracing, they think of it as a kind of a monolithic all or nothing technique. You have to either use traditional rasterization or you have to go all in on ray tracing. But in fact, ray tracing is a very flexible technology that you can use to incrementally add realism to your rendered scenes. And at its essence, it's calculating how light rays intersect with objects and materials and light sources in your scene, and you can use that basic idea of firing rays to implement a whole variety of different visual techniques to increase visual realism. I've shown some of them here on this slide. So how do you actually do ray tracing in Vulkan? So Vulkan provides two different ways for an application to fire these rays into a scene to calculate the ray intersections with the scene geometry and undertake flexible programmable calculations when you find an intersection to process the materials and the objects that you have found through that intersection. The first method, and probably the kind of the default way, uses a completely new ray tracing pipeline within the 3D API. It enables the developer to fire a grid of rays into a scene, and every time you find an intersection with the geometry, you get to choose what shader runs. A lot of the housekeeping around deciding what shaders are going to run and how many hits you get are automatically controlled by the machinery defined by this ray tracing pipeline mechanism. The second method, called ray queries, gives you a more manual control for the developer how they cast rays. Essentially, we're giving the capability of any normal shader in a 3D program, for example, vertex shaders or fragment shaders, to fire single rays into the scene, and they get to handle through their shader program how they want to handle those intersections. So they can do essentially anything they want with those intersections. So next I want to talk about Open XR. Open XR is Khronos standard for cross-vendor, portable, augmented and virtual reality applications. Open XR defines a common API that all of the XR hardware runtimes, that's the runtime that runs on your HMD device, can expose their functionality to application and engine developers. So this enables engines and applications to be written once, and then they can run on any XR compatible hardware that supports the Open XR API. As well as providing portability across different hardware, it's been very interesting to see Open XR evolve. It's enabled the industry to come together to learn from the first generation proprietary APIs that shipped on hardware like the Vive and the Oculus hardware. These companies have come to collaborate, and they've created a new generation XR API with really quite cutting edge capabilities. So the API is not just portable, it's a step beyond what the proprietary previous APIs were able to achieve. And it's great. We have a kind of a who's who of the leading AR and VR companies from the industry that are participating in the working group to create and deploy this standard. So Open XR, it's still early days, though we are now beginning to see its rollout across devices. The version 1.0 specification was publicly released at SIGGRAPH 2019, so that's back in July, and was supported from day one on Microsoft HoloLens 2 and the Monado open source XR engine from a company called Collabora, and Ryan from Collabora was presenting here yesterday. And that runs on any Open HMD compatible hardware. Since the launch, OpenXR is now shipping on Microsoft's mixed reality headsets, as well as the HoloLens and the Oculus Rift and Quest HMDs. It's available as a plugin to the Unreal Engine, and there are many more implementations in development. In the next few months, I think you're going to really see the rollout of OpenXR across an increasing number of hardware HMD devices. In parallel, the OpenXR working group, we're finalizing the conformance test suite, which is an important part of any standard. It's going to ensure consistent portability across all of these different OpenXR compatible implementations. So I think the reason why OpenXR is beginning to gain such wide industry adoption is it's a win-win for all involved. And everyone wins here. Software developers, the most obvious ones perhaps, they win because they can write an application once and ship it on multiple hardware platforms without having to rewrite and report their software. That saves them both time and money, and it lets them reach a much larger audience than just developing for one particular hardware platform. So XR hardware vendors win if they choose to expose the OpenXR APIs on their platform, because they can have access to a much larger library of OpenXR compatible applications. And of course, most importantly, end users win because they know that the XR applications that they want is going to run and be compatible with the system that they've just purchased. And that grows confidence and it grows the XR market for everyone. So OpenXR, it contains everything you need for an application to drive the XR devices in a system, including the discovering devices, doing the event processing, doing the sensor tracking, the pose calculations on the input side. It lets you control the frame display timing and composition of the augmented and virtual reality scenes on the output side, plus haptics on the output side too. The only thing OpenXR doesn't have is 3D rendering, and so OpenXR will be used next to a rendering API, such as Vulkan, to generate the 3D imagery. OpenXR can be used for any 3D API, but new generation API such as Vulkan, as we've already talked, is well suited to XR because it has the high performance and low latency that is really important for a compelling XR experience. So we talked about Vulkan and OpenXR. They are both native APIs. You call them from native applications. But the Metaverse, in my opinion, now the Metaverse is this openly connected and searchable virtual spaces and assets that we all kind of dream about. I think it's likely to evolve out of the World Wide Web. And so it's critical that the industry bring this XR capability to the browser. And the good news is that Khronos and the W3C, that's the World Wide Web Consortium that builds a lot of the web standards in the industry, we are cooperating to bring 3D and XR capability into the web stack. So all 3D in a browser today, if you've done 3D in your browser, uses WebGL. That's a Khronos standard that defines a JavaScript binding over native 3D APIs, and it's used by popular 3D engines such as 3.js and Babylon. Now we have the Open XR native API exposing XR hardware. Khronos is working closely with the WebXR working group at W3C to bring that capability into the browser. So just as native XR applications use Vulkan and Open XR together, XR applications in the web are now beginning to use WebGL for the 3D and WebXR together, with those web APIs reaching down into the Khronos native APIs for acceleration and hardware portability. And it's great that the industry, the various standards groups throughout the industry are working together to make all the pieces fit together and work together nicely. The last presentation was talking about 5G and smart glasses. OpenXR has a part to play too, as we kind of roll out that kind of system. OpenXR can provide application portability between different types of systems, such as edge served applications, as we're showing here. So this is a typical edge server architecture. Uses 5G to connect a lightweight AR device to send its real-time sensor data to an edge server. The edge server processes that sensor data, maybe using machine learning, generates graphical augmentations that can be much more sophisticated than could be generated on a battery-powered device, because you have the full power of an accelerated server to generate your graphics, and those graphics are sent back to the device for display. From a programmer's point of view, the Open XR API can hide those round trips over 5G from the application. So you can have the same Open XR application running natively on an AR device or an AR device connected to an edge server. I think that's going to really help the rollout of applications onto this new kind of architecture where it's useful. So let me switch gears. Every XR application needs to access and display 3D scenes and objects. So I'd like to talk now about gltf, which is the Khronos 3D asset format that is focused on being ubiquitous and compact and easy to process. And so we like to call it the JPEG of 3D, as it's the last mile JPEG equivalent for 3D. It lets you easily transport and deploy your 3D assets wherever you need. gltf uses JSON to describe the 3D scene or the asset hierarchy, and then uses binary payloads to describe the data-heavy geometry, animations, and skin data. Textures are also included, typically as JPEG or PNG files. The latest version of gltf, which is gltf2, has PBR, or physically based rendering materials that use those textures to indicate how metallic or rough materials are, or how specular and glossy. These are techniques that have been quite widely used in the industry. And this results in very realistic looking objects that can still be rendered very efficiently, even on mobile devices. So support for gltf is now very widespread throughout the industry as companies realize the efficiency and the cost savings of having tools and applications and engines that can all communicate assets easily to each other. So all the companies shown here have all implemented gltf support, both in tools that generate gltf assets and engines and applications that ingest those gltf models. And I'm sure there are companies here. If your company supports gltf and your logo is missing, let us know. We would love to add it. It's a full-time job keeping that slide up to date, which is great. So talking about the roadmap for gltf, gltf is evolving to meet industry needs. And we are very close to finalizing the first item on our roadmap, which is gltf universal textures, we use a very cool technology called Basis Universal from a company called Binomial. It's royalty free. So we have a KTX2 wrapper. That's a wrapper around the textures to provide consistent cross-vendor access to texture assets such as different map levels. And the transcoding of the textures enables smaller than JPEG textures that are directly transcodable to pretty much any GPU accelerated texture format on the fly. So it's very easy to bring these textures accelerated into your GPU, and they never have to be decompressed as fully decompressed images on the GPU. Next up on the gltf roadmap is second generation physically based rendering that takes us beyond the current metallic roughness specular glossy model and will include properties such as clear coat, varnishing and subsurface scattering. This will start rolling out soon as a series of extensions, starting with clear coat. And we have a number of companies in the industry helping us to find the right balance between good capabilities and still making gltf easy and efficient to process whatever device you're on. There are lots of feature requests coming in for gltf due to its success. We'd love to get your input and requirements, what you would like to see in gltf. We have the interesting task of finding the right balance between adding more functionality but not losing gltf's core goal on being focused as an ubiquitous, easy to process 3D delivery format. So it's very interesting discussions ongoing. So the last topic I want to talk about is the most recent initiative at Khronos that I think will positively impact the XR industry. It's the recently formed 3D Commerce Working Group. The basic technology to use AR in online retail has been around for many years. For example, some of you may have tried out the IKEA AR shopping app that lets you drop IKEA furniture into your own front room. That shipped back in 2013. And such pilot projects showed that AR was indeed effective for driving customer engagement and increased sales. So why isn't 3D commerce more ubiquitous than it is today? As you talk to many people in the 3D commerce industry, now we've come to realize that in addition to having the right acceleration and portability APIs, the main barrier to rolling out 3D commerce at industrial scale is the process friction around hundreds of companies trying to cooperate over the design and the manufacture and the presentation of millions of products across multiple platforms. If you talk to online retailers trying to use 3D models in their selling process, there are so many horror stories of process incompatibilities, from the complex down to the seemingly trivial ones, such as no one can agree on what direction is up for 3D models. And that kind of sounds trivial until you think what that means for a retail website trying to use 3D and trying to import thousands of 3D models a day. That's a huge burden and friction on deploying those 3D models. So the desire to solve those issues has prompted a number of retail companies such as IKEA, Amazon, and Target, and more to approach Khronos as a safe space to cooperate where there is already good 3D expertise to create standards and guidelines to enable 3D commerce at industrial scale. And we now have a strong quorum of these participants, including a unique mix of retail, technology, and platform companies, and they're all working together to truly enable the widespread use of 3D in retail. The 3D Commerce Working Group is working to ship initial guidelines and standards this year solving the first round of these urgent process issues around creating and configuring assets and ensuring that they can be faithfully displayed with sufficient visual realism, regardless of the end user's device. This work is leveraging GLTF and is in turn inspiring GLTF's evolution, including the new generation PBR model I mentioned to accurately display a wide number of products. And GLTF's also being upgraded to handle advanced metadata, which is one of the essential pieces that the 3D commerce industry needs. So the streamlining of the content and deployment of 3D assets at scale like this, I think will not only benefit 3D commerce, but it will have a positive impact on deploying all types of virtual and augmented reality applications and solutions throughout the industry. So that's it, the end of my presentation. Thank you for being here. I hope you found it interesting and useful. If any of these Khronos standards are relevant to your business, as I mentioned at the beginning, any company is welcome to join, to have a voice and a vote in our evolution. Memberships start at $3,500 a year for smaller companies. And if that's too much, you can apply to join one of the advisory panels that we run that provide requirements and specification feedback to the working groups. And that's for free. I've provided some links here for more information, and if I can help in any way, I'll be around the show here and be glad to talk to you. Thank you.
Many thanks, Niels, for your presentation.
Thank you. Is that slash clap?
Yeah.
Oh, cool.
F4. Yeah, we have some questions on the public chat. If you want to look at this.
Sure. Yep, I see a
Thank
question.
You.
Yeah, I see a question here. What's the difference between Open XR and WebXR? So that's a good question. So they are very similar in terms of the functionality. The way they differ is where they are in the software stack. So OpenXR is a native API. So that means it would be implemented by the HMD manufacturer. So a company like Oculus or Vive, when they ship their HMD hardware, they would include the OpenXR API, which is a C API. And if you're writing a C application that isn't using the web, no, you would use the OpenXR native API directly. WebXR kind of exposes that similar functionality to JavaScript for the web developer. So again, similar functionality, different API, and of course you're exposing that functionality in the web stack. So there's now web ways of doing things, but the functionality is basically the same, but it's a JavaScript API. So the JavaScript web applications will call into WebXR. But the reason we call it a stack is a web developer developing a web-based XR application would call WebXR. With the implementation of WebXR can then call down into the hardware API, which is OpenXR. And that way they can get portability. The WebXR implementers can get portability across many different hardware devices. So the two kind of work together. They're actually running together in the same stack at the same time. It depends on where you want to program. I see does OpenXR handle eye and hand tracking? The answer is yes. The OpenXR has a very forward-looking input architecture. That's one of the nice challenging things about designing a API that is not intended just to run on one type of hardware, but will run portably across many different types of hardware, including into the future, where there are types of input devices we haven't even imagined yet. The OpenXR standard has very flexible input framework that lets you define and control new types of devices as they appear. And we have people that are working to put extensions into OpenXR for the kind of new generation of devices, and eye tracking is a great example of that. I think over the next 12 months, you will see Open XR implementations with eye tracking. The initial implementation of Open XR on HoloLens 2 that was released on day one of the spec, it already was handling the hand tracking from HoloLens 2, for example. So the answer is yes. There's a question here. Can you comment on Inari? Yes. Okay. I didn't mention Inari, but I'm happy to do that. Inari is actually our very newest working group. It's a working group that's focused on analytic rendering. That's where the name comes from. And the best example of analytic rendering is scientific visualization, where the rendering process is not being driven by trying to simulate a room or a conference hall like we're in today, polygons making up the floor and the walls, but driven from data, scientific visualization data. You might be trying to visualize molecules, or visualize how airflow over an aerofoil, something like this. Inari is intended to make that kind of application very portable and very performant. The difference between Vulkan and Inari, with Vulkan, you get to draw every polygon, every triangle. You're basically piecing together what's on the screen from the triangles up. With Inari, you simply describe the data that you have and where it sits in the scene, and Inari will take everything from there and will render the scene for you. It's much higher level. And Inari will call down into Vulkan in the end to render the polygons, but it gives you a lot of flexibility. The developer doing scientific visualization can call Inari saying, here's my data, and I want to use this renderer. That renderer might be using new generation technology like the ray tracing we were discussing to produce the highest visual fidelity. But it doesn't have to. You can use any backend renderer to suit your application, and Inari hides all of that low-level rendering detail from you. So we want to enable scientists to focus on their science, not having to become 3D graphics experts. People doing virology research right now. They're it's good if we can enable them with better tools. I'm looking down here. There's a few more questions here. Yeah, so there's a question here. Is Khronos working with some of the memory cache or sequence 3D formats such as volumetric video, OBJ sequences, Alembic? The yes and no. We absolutely support application developers' formats like Alembic and others are definitely very important. And anyone rendering an Alembic file will eventually come down to use a low-level API such as Khronos. Alembic, though, is not a Khronos standard, but that's okay. From terms of the 3D formats, we are focusing on gltf because in many ways gltf is the asset format that needs to be closest to the hardware. And hardware acceleration is Khronos's focus and expertise. gltf is close to our heart because gltf is designed to be very efficiently unpacked and decoded and accelerated and displayed on the hardware using our low-level APIs. File formats like Alembic and USD and others are higher level, typically more used in the authoring process, and they will be processed typically by applications before they get down needing to be accelerated on the hardware platform. So yes, we absolutely do love and support those formats, but they're not Khronos formats per se. But as I say, it's great that the industry is working together to make sure all of these different pieces work together in a good way. So question, there are ideas about possible gltf file encryptions. So yes, security and encryption is a topic that often comes up around gltf. So far, the direction of the gltf working group around encryption is, we understand that it's important for many application areas, but so far we haven't come across a use case that would mean that we have to do it in the gltf standard itself. If someone wants, for example, we can use secure packaging technologies to encapsulate your gltf format assets. So, for example, you can distribute your assets in a password protected, encrypted zip file, and unpack those assets into native gltf and then feed it down into the hardware. So far, that has been enough encryption to satisfy the use cases that people have come to us with. There are probably use cases that may need us to start building encryption into the native format itself, but so far, not yet. But again, if that's an interesting requirement that you have that wouldn't be satisfied by packaging, come talk to us. We'd love to understand that use case. Is the Khronos Group working on a usable gltf plugin for Unity? Yes. So both the Unity engine and the Unreal engine, they're increasingly getting more robust gltf import, and on the tools side, in some cases, export too. It's a rollout, so there are sometimes issues with early versions of importers, exporters. The gltf working group, though, we always make sure that we have an open source kind of what we'll sample implementation of a importer and exporter that we know is fully functional and works well. And that very often is very helpful for new engine and tools vendors as they're first coming up the gltf learning curve. So yes, all of the major engines pretty much now are rolling out pretty good gltf import and export. If you do come across issues, the best way to get in contact with everyone is to come on to the Khronos GitHub repo. There's a repo there specifically for gltf. Now, please do report any issues that you find. We have the Unity and the Epic guys there in the working group, and they, I'm sure, would love to get your input, and we can make sure that the importers and exporters are working well. It's really important that the importers and exporters work well, because if they don't, then people start assuming that a broken version of the file format is normal, and that way you get dialects of the asset format, and people get confused. So we're really working hard to make sure that all of the importers and exporters out there process gltf in the correct way.
Maybe last question, Neil, to be on time.
Yeah. Okay. Let's see.
gltf is a good subject. Many questions about.
Sure. Yeah. There's a question here. Some behavioral animations, not just static animations. Yes, that's a good question. At the moment, gltf, we have what I call fairly well understood classic animation. So a gltf file can include model animation and skinning. That's already shipping in gltf2. We do have, it's one of the items on our roadmap, is more advanced behavioral based animations, actually more precision around animations too. The use case that many people have come to us with is, for example, face emojis, where it's quite subtle and quite detailed animation. It would be quite hard to do really compelling facial animations with the current level of animation that we have in gltf. So that is definitely an item on our roadmap, and we actually are working on animation version 2 for gltf that will roll out as an extension at some point, if that's of interest to you. As with anything with gltf or any of the Khronos standards, even if you're not a member, please come onto our website and our GitHub repos and tell us if you're hitting problems, or if you have requests for functionality that we don't already support. We really genuinely love that input.
Yeah. Many thanks, Niels. Many thanks to be here.
All right.
Thanks.
Thank you very much, everyone.
And of course, you have the contact of Niels, and you are very, very engaged to contribute to Khronos Forum. Thanks.